Hey everyone, in this video we're going to talk about section 3.2a, which will introduce our third and final existence theorem, the extreme value theorem. So this video will introduce the theorem in terms of pre-calculus concepts, but in 3.2b we'll connect it back to calculus. So first let's talk about absolute and local extrema. So this text box, that we have right here, kind of is the textbook definition of what constitutes a maximum or minimum as absolute or local, but I'm more interested in looking at this picture. Sorry, it's kind of blurry. So when we're talking about a maximum, we're saying that that point is higher than the points either directly to the left or directly to the right of it. So we have a maximum here and we have a maximum here. Now the difference between a local and an absolute maximum is the absolute maximum is going to be the absolute highest point on that graph. So here, this point is not only higher than the points left or right of it, but it is the highest point altogether. We have the same thing for minimums. We have 3 of them on this graph. And the absolute minimum just means that this is going to be the, I hate to use the word in the definition, but it's going to be the absolute lowest point on the graph. Now notice here that minimums and maximums can occur at the endpoints. So when we have endpoints, we need to take those into consideration as being a maximum or a minimum. And so here, the absolute minimum is an endpoint. All of this is going to lead us into the extreme value theorem. So you can pause the video, take a second to read this definition, and then we'll pick back up in a second. Okay, so reworded, the extreme value theorem says that if a function is continuous on a closed interval AB, then we can guarantee that the function will have a maximum and minimum value on the interval. And actually, I want to add to this, I want to say that it will have an absolute maximum or minimum. Okay, and so we can see this here. So if we're on a closed interval, yeah, we might, kind of go up and down. So we're guaranteed to have an absolute highest point and an absolute lowest point, okay? We can see that here. Here's our absolute highest point. Here's our absolute lowest. We can see this here. Here's our absolute highest point and absolute lowest point. So you might be thinking, well, Ms. Dollens, this is probably always true for things. Well, not always, because if we look at this graph right here, okay, I see it's always decreasing. We have our absolute highest point and our absolute lowest point. If this had not been on a closed interval, this function would have looked like this. We wouldn't have had a, not only an absolute max or min, we wouldn't have had any max, or we wouldn't have any max or min. So the extreme value theorem only applies if we're examining a function over a closed interval. Now, again, that's not to say that we can't have maxes or minimums, but when we have a closed interval, we're guaranteed to have an absolute max and min. So going on over to our next page, I see that we have 2 graphs, graph A and B. We're going to list all the extreme values of both graphs. So why don't you go ahead, pause the video, try listing out the extreme values, where they occur, and if whether they're absolute or local maxes or mins. Okay, welcome back. Hopefully you've had a chance to. All right, so let's see what we have. So looking at graph A, I see here that we probably have some sort of minimum value at x equals 0, right? And if I'm looking at this graph, well, that seems to be the lowest point on this graph. So I'm going to say that we have an absolute min. And let's say what that minimum value is. That's an absolute minimum of 0, and it occurs at x equals 0, okay? Now, again, I guess I should have defined this before, but we have a closed domain on graph A, right? It's kind of some sort of parabola, probably is x squared, but it's not the full graph. We're given just a finite portion of it. So it looks like our domain is -2 to 1. So because I have some endpoints, I'm going to go ahead and include those as well. So looking at our endpoint of -2, I see that that's going to be a maximum, and it's the highest point on the graph, right? No other point on this graph is going to be higher than it. So I'm going to say that we have an absolute max of, let's see, where does that occur, of 4, and that occurs at x equals -2. And we have another maximum. It is a maximum, but it's not the highest point. So I'm going to say that it's just a local max of 1 at x equals 1. Neat. Okay, and just one thing to keep in mind is that we had our endpoints here. Okay, looking at graph B, I think that this is, yep, this looks like it's the same graph, except we don't have a restricted domain. So our domain is -infinity to infinity. So what that means is I think we're just going to have one point here, right? We still have our minimum of 0 at x equals 0. And in this case, if I'm looking at this graph, this is the lowest point. That's going to be the lowest point that ever exists on this graph. So again, I'm going to say that this is the absolute min of 0 at x equals 0. Okay, so looking at these two different graphs, only one of them is going to apply to with the extreme value theorem. Can you guess which one? Well, it's going to be graph A. The reason being is that we have a closed domain AB. That's a C, closed domain. So I'm going to go back over to that last page. I don't think I did a very good job really emphasizing this, but we have to be on a closed interval for the extreme value theorem to occur. And when we have a closed interval, we are guaranteed to have an absolute maximum and an absolute minimum. If we don't have a closed domain, like we see in graph B, we might have an absolute minimum, but we are not going to be guaranteed to have an absolute maximum. Okay, going down over to example 2. So we're going to take a second, I'll have you pause the video and examine this graph, and then we are going to answer these 3 questions. So why don't you go ahead and try it out, okay? Pause the video, look at this graph, try to answer yes or no, and consider what your justifications are going to be for these 3 questions. We'll go over it. All right, welcome back. Hopefully you've had a second to think about it. So let's examine this graph first. So I see that we kind of have a piecewise function going on here, and I see that it is not a continuous graph, right? We do have a jump discontinuity here. So, or a removable discontinuity, I guess. Okay, so I don't even know what I'm saying. Question 1, is there an absolute maximum? Why or why not? Hopefully you said no. And the reason being is that when we're looking at where that absolute maximum would occur, I don't think the point is defined there, right? So like when we're looking at this point here, this is occurring when x is equal to b. And I see here that this point is f of b. But this point right up here, whatever this is not actually that other point. Like let's say this is 6, for instance, okay? I know that when we approach this from the right, we can get closer and closer and closer and closer to 6, but we're not actually ever going to obtain 6. So because we're not going to obtain that value of where the absolute maximum would occur, we can take the limit, but the function doesn't exist there. So because there isn't actually a point at that absolute maximum, there is no absolute maximum. So I'm going to say f of b is not in the range. And I'm going to say because b is not in the domain at that point. Okay, so what's important though is b is in the domain, but it's only in the domain of that first function. It's not in the domain of the second function. Okay, question 2, is there an absolute minimum? Why or why not? I am hoping that you said yes. Okay, let's think about why. So is there an absolute minimum? Well, looking at our graph, it looks like it's occurring at D. There's actually a point there, like the point is defined there. This is f of D, so because D is defined at that absolute minimum point, there is an absolute minimum. So I'm going to say yes, f of D is an absolute min. D is in the domain. All right, the last question. Does the extreme value theorem apply to this function on the interval, the closed interval a to d, why or why not? I am hoping that you said no, and the reason being is that this is not continuous, and it's also not on the closed interval, right? If we're looking here, well, a is not included in the domain there, so there's no way that this can happen. So, not continuous or on a closed interval. All right, so this here introduces us to the extreme value theorem. In the next video or the next section, whether you're going to watch that as a video or it is in class, we will be discussing how calculus will help us out and how we can calculate maximums or minimums without having to look at the graph and, as you guessed it, use calculus. Okay, that's all for now. I'll see y'all later.